So today we will talk about equilibrium and reversible reactions. So as the name suggests, a reversible reaction can be reversed, right? What does it mean? Normally, a reaction goes from product that it makes and reactant that it uses to make them. Usually that is the way a reaction happens. But in a reversible reaction, the products also get decomposed or react with each other and go back to becoming reactant. A few common examples: nitrogen reacting with hydrogen to produce ammonia. It is estimated that almost 2/3 of the world population owes their life to this reaction. Why? Because this is the reaction that we perfected, we understood to be able to make fertilizers. And those fertilizers were then used to feed the world. Without knowing this reaction or how it works, we will not have that much population growth in the world. Right now, usually in the industry, here's what happens. Whenever we do this reaction, we use 450 degrees Celsius temperature, 200 atmospheric pressure, and iron catalyst. And those are conditions you're supposed to remember. This reaction is called Haber process, named after Haber, a very good friend of Einstein, and who perfected this whole idea. The second reaction that we usually use is the one that we use in contact process. Again, contact process ka reaction kya hota hai? That you start with sulfur dioxide, reacts with oxygen, produces sulfur trioxide. Now, even though sulfur dioxide and sulfur trioxide can cause acid rain, Assalamu alaikum, they are still both very useful when it comes to producing many things. So for example, sulfur dioxide is used to bleach wood pulp. Kyun? Wood pulp ki kisko zarurat hai? Who needs wood pulp, and on top of that they want it bleached? Who needs it?
Sir, to make paper.
Yes, very good. So to make paper. Similarly, sulfur dioxide is an acidic gas, so we use it whenever we are packaging food, canning food. Similarly, sulfur trioxide is used to produce sulfuric acid, which is arguably one of the top 5 most used chemicals in the world. The conditions for this reaction are, again, 450 degrees Celsius temperature, but low pressure, 122 atm, and V2O5 catalyst. Both of these reactions are exothermic. So here's what happens. Normally, when a reaction happens, you start with some reactants. Those reactants get used up, and eventually all of them reach a zero level, or at least the limiting reactant reaches a zero level. So green is the concentration of limiting reactant. When this happens, we say, like when it reaches zero, we say reaction is complete. Okay, so reaction is complete because concentration has become zero. So ye concentration hai, and this is time. Here's what happens. In a reversible reaction, this state never comes. In a reversible reaction, the reactant starts to decrease, sure, it gets used up, and eventually it reaches a constant stage. It does not go down to zero. Okay, so this is a reactant. And not just that, the product starts from zero, and it also reaches a fixed value. Again, this value can be high, low, whatever. मतलब वो जरूरी नहीं कि यहाँ पे वो इस ऊपर भी जा सकता है, लेकिन उसकी एक वैल्यू फिक्स हो जाती है. ओके, इस तरह इसकी भी वैल्यू भी फिक्स हो जाती है. And when this happens, this situation, we say equilibrium is established. So अगर तो आपका reactant full zero हो जाए, तो उसका मतलब reaction complete हो गया, और that's it. अब और reactant तब तक नहीं होगा जब तक आप और limiting reactant add नहीं करते. But अगर वो zero भी ना हो, लेकिन उसकी वैल्यू ना कम हो ना ज्यादा हो, उसको बोलते हैं इक्विलिब्रियम. अब इक्विलिब्रियम पे रेट का क्या इफेक्ट होता है? रिएक्शन इज स्टिल गोइंग ऑन. ऐसा नहीं है कि ये रिएक्ट कर नहीं रहा, रिएक्ट कर रहा है, लेकिन जितना रिएक्ट करके इसकी वैल्यू नीचे जाती है, प्रोडक्ट उतना ही रिवर्स में जाके उतनी वैल्यू को ऊपर ले आता है, एंड ओवरऑल वैल्यू स्टेज द सेम. So all the amount that gets used up is regenerated at the equilibrium at the same speed. Imagine if Apple sold M1 chips to Samsung and Samsung sold LEDs, वो तो वैसे भी सेल करता है, to Apple. अब Apple उनसे आईफोन बना रहा है और Apple आईफोन के प्रोसेसर सेल करना शुरू कर दे Samsung को. There will come a time when both of their businesses are happening at the same amount. In that situation, the profit that Apple makes from Samsung may be the same amount that it pays to Samsung for those LED screens. Business तो हो रहा है ना, चीजें खरीद भी रहे हैं, बेच भी रहे हैं, लेकिन profit नहीं हो रहा है because all the profit that they make, they are spending it again. ऐसे यहाँ पे all the things that they make, they are then reversed and they create the things that were used to make them. Reversible reaction में हम कहते हैं this stage is when the rate of forward reaction equals the rate of backward reaction. This situation is called equilibrium. Not एक तो ये बात होगी. दूसरा, you can see concentration becomes constant. So concentration of reactant and products becomes constant. Remember, they are not equal. Not equal. It just becomes constant, just like over here. वो change नहीं हो रही है. वो equal होना जरूरी नहीं है. हाँ, equal हो भी सकती है, but जरूरी नहीं है. लेकिन rate equal होना जरूरी है. Okay? So that's the idea of equilibrium. So exam में वो कहता है कि equilibrium क्या होता है. Acha. Now let's suppose you're somebody who has invested a lot of money in building a factory that produces ammonia. You are paying salaries. You have invested a lot of money. You are paying the electric bills, the fuel bills to heat it all up to this cost. You are paying the very heavy cost to get material or equipment that can withstand these conditions. 200 atmosphere is no small thing. And you invest all that money and ammonia is made, but your factory is running और जितना ammonia बन रहा है वो उतना ही है. These values you need to memorize, by the way. आपकी factory चल रही है, आप लोग काम कर रहे हैं, you have to pay salaries, you have to pay electric bills, all of that. लेकिन ammonia नहीं बन रहा, जितना बनना था उतना ही बन गया. You can't make any more profit. You will hate it. Dynamic equilibrium is something nobody wants. You will hate it because it's eating up your profits. You're not making any more. So you would want to obviously disturb the equilibrium. You don't like it. You don't want equilibrium. You want that the reaction keeps producing ammonia. You want the reaction to be forward more and backward less. The nature of this reaction is कि equilibrium तो आना ही आना है. हाँ, आप ये कर सकते हो कि equilibrium को आने से पहले disturb कर दो, उसको delay कर दो, या अगर equilibrium establish हो जाए, you disturb it. What do we want? We want the forward reaction to be faster and the backward reaction to be slower. This is called, we want equilibrium to shift forward. When we say equilibrium shifts forward, इसका मतलब है forward वाला तेज है, backward वाला slow है. Equilibrium का है जहां पे forward और backward एक बराबर है. But you want the forward to be more. And why is that? Because you want greater yield. What is yield? The concept of yield is कि आपने फैक्ट्री लगाई थी, you expected कि मेरा per week 100 tons ammonia produce होगा. But when you do the reaction, turns out only 70 tons is produced. So you are getting 70 where you wanted to get 100. Your yield is 70%. It is the practical value over the calculated value. This is also called theoretical value. Calculated value times 100%, that is your percentage yield. Basically हम क्या कह रहे हैं? हम कह रहे हैं कि देखो जो theoretical value है ना, जो calculated value है, that is 100%. तो जो प्रैक्टिकल वैल्यू है वो हमारा x% है, and we use the ratio method to solve it. Okay, so for example, if you had enough material to produce 1200 tons per week, but after a week you could only produce 800 tons, so this is your calculated value कि अच्छा मेरे पास 1200 का सामान है, and this is what is actually produced. So your yield is going to be the two methods that are there. You assume that 1200 was 100%, so 800 is x%. So you cross multiply it. So 1200x equals 800 times 100%. So x is going to be 800 over 1200 times 100%. So this comes out to be what? 66.7%. Okay, that's what you get. कि इतने परसेंट वो प्रोड्यूस होगा, बाकी नहीं होगा. Okay, another way of doing this, you just apply the formula. The yield is going to be 800 over 1200 times 100%. तो जो भी 66.7%. That's the yield that you have. Yield कब बढ़ती है? Yield increases. This is a very important point to remember. Yield increases when equilibrium shifts forward. When the backward reaction is slow and the forward reaction is less. Now, what happens to the remaining 33%? It does not get made. Or whatever is made goes in the reverse direction. So you can say that it is wasted. Turns out, even with the best technology, we will never be able to achieve 100%. Kuch na kuch wastage is natural. It happens. But when Haber started doing this reaction, when he started tackling this problem, us waqt the yield that we were getting was 17%. That is ridiculously low. So he found a process, diye wala process, which brought it up to 85% from 17%. इतनी बड़ी इंक्रीज है कि जैसे किसी का यू आ रहा हो ना 17% पे, तो उसका ए स्टार ले आओ. जो उसमें मेहनत लगती है ना, वो इसने मेहनत की है, इन कंडीशन से किया उसने. सो कैसे किया? हाउ डू वी रिवर्स, हाउ डू वी मेक श्योर कि इक्विलिब्रियम को हम कंट्रोल कर लें? फॉर दैट वी हैव टू अंडरस्टैंड कि इक्विलिब्रियम करता क्या है. इमेजिन इफ इक्विलिब्रियम वाज अ पर्सन. हमें उसके दिमाग को समझना है कि हाउ डज इट वर्क. इट्स अ गेम, इट्स अ स्ट्रैटेजी की गेम कि हम क्या करेंगे और आगे से वो कैसे रिस्पॉन्ड करेगा. तो हमने उसके साथ रिवर्स साइकोलॉजी खेलनी, और उसका बड़ा सिंपल सा प्रोसेस है. हमारे पास, हमें इक्विलिब्रियम का दिमाग समझ आता है. देयर इज द रूल LCP. दिस रूल टेल्स मी हाउ इक्विलिब्रियम बिहेव्स. अगर मुझे LCP आता है, मुझे पता है इक्विलिब्रियम को कंट्रोल कैसे करना है. बड़ी सिंपल सी बात है. इफ आई अंडरस्टैंड योर माइंड, आई विल बी एबल टू कंट्रोल यू, राइट? Insert evil laugh. Just like that, if you understand LCP, we will know how to control it. So LCP says that equilibrium will always opposes any change on it. Very simple. It is like Newton's third law for chemistry. वो क्या कहता था? Whatever you do, whatever force you apply, the force will apply in the opposite but equal amount. उसकी डायरेक्शन रिवर्स हो जाती है. I'm sorry, I botched it. It's basically the law says that every action has equal and opposite reaction, right? So whatever force you apply, you will get an equal force, but in the opposite direction. And that is how we swim. That is how we walk. That is how we hang things through friction. So LCP tells me that equilibrium will always oppose whatever change you put on it. So in other words, what changes can I put on it? I can increase the pressure. I can increase or decrease the temperature. I can increase or decrease the concentration. Because rate को तो यही चीजें control करती थी ना. There are two other factors, surface area, जो हमने उस दिन बात की थी, and catalyst. Turns out catalyst does not affect equilibrium. That is an important point. Catalyst does not affect equilibrium. Kyun? Because catalyst does not affect yield. Kyun? Go back to the graph that we had. हमने इक्विलिब्रियम, हमने एनर्जेटिक्स में ग्राफ देखा था. रिएक्टेंट से स्टार्ट करते हैं, प्रोडक्ट पे एंड करते हैं. When I add a catalyst, I start here, I end here. Notice I'm still starting here, I'm still ending here. Equilibrium or the amount does not get affected by the catalyst. ठीक है, मैं explain करता हूँ. Don't worry, I'll explain again. So this is with the catalyst. When you are not using a catalyst, this is the activation energy of the forward reaction. And this is the activation energy, this is the activation energy of the backward reaction. ठीक है? This is activation energy of the forward reaction. This is activation energy of the backward reaction. When I am using a catalyst, this is my activation energy of the forward reaction. And when I'm using a catalyst, this is the activation energy of the backward reaction. Do you see that both forward has been decreased and the backward activation energy has also been decreased? Equilibrium is not affected. Why? Because equilibrium only gets affected when one side is faster and the other is not. यहाँ पे तो दोनों फेज होगी. Catalyst lowers activation energy of both sides. So both are faster. Equilibrium remains unchanged. Yield remains unchanged. The only two things that affected is pressure, temperature, concentration, not surface area, not catalyst. Okay? Now let's understand LCP again. LCP means Le Chatelier's principle. Le Chatelier's principle. Whatever we do, equilibrium will oppose it. Matlab, if I increase the temperature, equilibrium will try to decrease the temperature. Reactions are either exothermic or endothermic. Which of them decreases the temperature? बताएं. Endo or exo?
Endo.
Endo. शाबाश. So अगर मैं temperature increase करूंगा, इक्विलिब्रियम उसको डिक्रीज करेगा, मतलब एंडो की तरफ जाएगा. मैं टेम्परेचर डिक्रीज करूंगा, वो उसको इंक्रीज करने के लिए एक्सो की तरफ जाएगा. बहुत सिंपल सी बात है. तो लेट्स लुक एट दिस रिएक्शन अगेन. मैंने लेट्स सपोज 450 डिग्री सेल्सियस टेम्परेचर कर दिया, वेरी हाई टेम्परेचर. तो इक्विलिब्रियम विल गो टुवर्ड्स द एंडोथर्मिक साइड. व्हिच वन इज एंडो? बैकवर्ड और फॉरवर्ड?
Backward.
Backward. Shabash. Because this side is negative, so this will automatically be positive. So it will try to go backward. And remember, if the reaction goes backward, yield decreases. If the reaction goes forward, or basically the equilibrium goes forward, yield increases. So yes, Aslan, you're right. Temperature will affect the yield. So at high temperature, this will reduce my yield. जितना अमोनिया बनना था उससे कम बनेगा. पहले अगर 80 टन बना था, अब 50 टन बनेगा. We will come back to this point in a bit. आगे चलते हैं. प्रेशर की बात करते हैं. Pressure depends on gases. Solid and liquids are unaffected by pressure. हमने ये पढ़ा था. So this means that we have to look at the gases. मेरे पास यहां पे ये गैस है, ये गैस है और ये गैस है. तो जरा देखते हैं. I have 1 + 3, 4 moles of gas on the left side, or the ratio is 4, and I have 2 on the right side. इस इक्वेशन को मुझे देखने के लिए सिर्फ ये देखना है, इधर 4 है उधर 2 है, बस. That's all that matters for me. So 4 के पार्टिकल ज्यादा होंगे कोलिजन ज्यादा होगी, प्रेशर ज्यादा होगा। 2 के पार्टिकल्स कम होंगे, मोल्स कम है ना, कोलिजन्स भी कम होंगी, प्रेशर भी कम होगा। सो इसका मतलब है अगर इक्विलिब्रियम फॉरवर्ड आता है तो वो मोल्स कम करेगा, तो प्रेशर कम होएगा। अगर वो बैकवर्ड जाता है, वो मोल ज्यादा करेगा, तो प्रेशर भी ज्यादा हो जाएगा। अब मैंने 200 एटमॉस्फेरिक कर दिया है, I have a very high pressure here. The equilibrium will automatically try to reduce it. तो किस साइड पे जाएगा, फॉरवर्ड या बैकवर्ड?
Forward.
फॉरवर्ड जाएगा। It will try to go forward because there is less gaseous moles there. और यही तो मैं चाहता था। अगर वो फॉरवर्ड जाएगा, यील्ड बढ़ेगी ना, तो ये तो हम चाहते थे। हमने फैक्ट्री लगाई किस लिए? इसीलिए तो लगाई है। So this is a good thing. Catalyst does not affect my yield, but it saves me a lot of time. So we still use a catalyst. इस रिएक्शन को देखते हैं। इसमें हमने प्रेशर ज्यादा क्यों नहीं किया? इधर 3 है, उधर 2 है। अभी भी प्रेशर अगर ज्यादा करेंगे तो फॉरवर्ड ही जाएगा ना, ये 3 से 2 पे जाएगा। लेकिन हमने प्रेशर कम रखा है। एनी आइडियाज क्यों? सेफ्टी, यस। This thing, this reaction, if you want to do it at high pressure, आपको बहुत strong cylinders चाहिए, आपको बहुत बेहतर इक्विपमेंट चाहिए, सेफ्टी रिक्वायरमेंट काफी ज्यादा हो जाती हैं, क्योंकि एक्सप्लोजन का हैजर्ड होता है ना, एंड दीज आर एसिडिक गैसेस, तो इनका एक्सप्लोजन बहुत डेंजरस होता है। सो टू सेव ऑल दैट कॉस्ट एंड हैसल, वी कीप द प्रेशर लो। इस केस में हमारे पास चॉइस नहीं है। अगर प्रेशर लो रखेंगे ना तो यील्ड बहुत ही कम आएगी, तो इसलिए वी स्टिल गो थ्रू ऑल दैट ट्रबल। अच्छा, सही है। अब लास्ट वन इज कंसंट्रेशन। मैं रिएक्शन ही कर रहा हूं, इक्विलिब्रियम एस्टैब्लिश हो जाता है। मैं एक काम करता हूं, मैं उस सिलेंडर में साइड से नाइट्रोजन पंप कर देता हूं, नाइट्रोजन ज्यादा कर देता हूं। सो व्हाट विल हैपन? इक्विलिब्रियम विल यूज दिस, जो आपने एक्स्ट्रा नाइट्रोजन डाली है वो उसको यूज करने की कोशिश करेगा। इस इक्वेशन में किस साइड पे नाइट्रोजन है, लेफ्ट या राइट?
Left.
लेफ्ट। दैट इज अ वेरी इंपॉर्टेंट पॉइंट टू रिमेंबर पीपल। ये नाइट्रोजन नहीं है, ये नाइट्रोजन है N2। दिस इज सिंपली अमोनिया। उसमें नाइट्रोजन यूज होती है, उसमें नाइट्रोजन है नहीं। नाइट्रोजन इज दिस। सो व्हेन यू पंप मोर नाइट्रोजन इन, it will get increased, equilibrium will go to the opposite side, so it gets used up, and that's again increasing our yield. So whenever we are doing this reaction, after a while we will pump more nitrogen in, pump more nitrogen in, pressure को maintain रखने के लिए, and secondly to make sure the equilibrium keeps on going forward. Okay, so I'm going to give you a question here. I have this reaction. Tell me, should I keep a high pressure or a low pressure? Pressure depends on gaseous moles. Gaseous moles. So if this is exothermic reaction, if I decrease the temperature, equilibrium will try to increase it. तो वो exo की तरफ जाएगा. तो good answer, Aslan. We should keep a lower temperature. Okay, so we should keep a low temperature. ये हम recommend कर रहे हैं अभी. Okay. What about pressure? Should I keep a low pressure or a high pressure?
Low pressure.
Low pressure. Why?
Because there are more number of moles at the forward side.
There are more number of moles on the right side. So that means there is high pressure on the right side. So अगर हम pressure low करेंगे, वो pressure को ज़्यादा करने की कोशिश करेगा, and that means it will try to go in the forward direction. Very good. Does everybody understand this? If you don't, please ask. Now is the time. Acha. If we keep a low pressure, let's look at the equation. The equation simply becomes there is 0 moles on the left side of gas and 1 on the right side of gas. Ye gas nahi hai, ye gas nahi hai. This is the gas. So this is the only thing that matters. 0 side has less moles, less pressure. 1 side has greater moles, greater pressure. By the way, ये नहीं होता कि pressure इस side पे होता है और इस side पे नहीं होता. This is all happening in the same container. It's just कि pressure इसकी वजह से है. So when you keep a low pressure, equilibrium tries to increase it. So it goes to the side with greater moles. तो इधर है ना, तो इधर को जाएगा. All right.
Sir, can you explain why low temperature?
Low temperature. Let's see. If I keep a low temperature, it will try to increase the temperature. And to do that, it should go in the exothermic side. और वो ये. So ये forward जाएगा because that side is exothermic. मैं टेम्परेचर इंक्रीज करूंगा तो ये एंडो की तरफ जाएगा जो कि बैकवर्ड है. तो मैं तो नहीं चाहता, मैं तो यील्ड ज्यादा चाहता हूं, तो इसलिए मैं इसको फॉरवर्ड भेजना चाहता हूं. ये बात सारी ठीक है, लेकिन अब ये इंडस्ट्री वालों को कौन समझाएगा? बिकॉज देखो उन्होंने क्या किया, एक एक्सोथर्मिक रिएक्शन है और उन्होंने 450 डिग्री सेल्सियस टेम्परेचर कर दिया. लेट मी एक्सप्लेन टू यू व्हाट दिस मींस. इसका मतलब ये है कि दे आर इंपोर्टिंग फ्यूल, they are paying a high cost of fuel for this. They have invested in getting better equipment that can withstand all that heat, all that pressure. And yet, इतने पैसे लगाने के बाद, इतनी इन्वेस्टमेंट, इतना कॉस्टली फ्यूल लेने के बाद भी they are reducing their yield because this is an exothermic reaction, ना? तो टेम्परेचर ज्यादा करेंगे तो it will go backward. What are they doing? Any idea? Why are they doing this?
Because they don't know.
That is one explanation. Or maybe they do know something that we have forgotten. There are other ways to increase the pressure or keep the pressure constant. In all of this, equilibrium kya karta tha? Equilibrium was when the rate of forward reaction is equal to the rate of backward reaction. Or hamara, any business, what do they want? They want to increase their profit, right? To do that, they need to make more of the product in less time. Time is money. जो बंदा जल्दी अमोनिया बना के डिमांड पूरी कर लेगा वो ज्यादा प्रॉफिट बनाएगा. They will sell more stuff. So what are these guys doing? What does temperature have to do with time? Tell me. In this reaction, what does temperature have to do with time?
The more the temperature, the faster the reaction.
Very good. When you have a high temperature, the reaction is faster. So it decreases the time. Very good, Iman and Asma. It decreases the time that you need to spend to get the yield that you're looking for. Lekin,
Sir, but
at the same time,
it decreases the yield.
it decreases the yield. Very good, Minail. Yield कम हो रही है, but let's see what it means. अगर मैं reaction को slow करता हूं, तो हो सकता है in 7 days I can produce 100 tons of ammonia, right? But what if I increase the temperature and I can produce only 60 tons of ammonia, but in 3 days? What will you do? Which option will you choose? Deal hai.
Second.
You will choose second, right? इसका मतलब है you have a lower yield and yet you compromise on it because you're saving time, and that is what these industrialists do. So this is an important point. Temperature is kept high even in exothermic reactions. It is a compromise to get faster या higher rate at the cost of yield. They will still make more money, and that is why they do it. All right, take care. Allah Hafiz.